Now today we will be going over double-ended queues, and in short we can write this as, it's not pronounced Deque, but it's actually pronounced as Deque. Deque is a type of queue, as the name suggests, where insertion and removal can be performed in either from the front or rear of the queue. So it does not follow the FIFO principle, where FIFO stands for first in and first out. So this is our regular queue, right? Let's say that we have our simple queue with 5 elements. Now in a regular queue, if we were to remove an element, it would always happen from the beginning of our queue. So first one would be this element, second would be this, third, fourth, and fifth. If we want to add an element, it's always going to be from the last or at the end of the queue. So it will be over here. So we can't insert it all the way at the front. We can't insert it in the middle. We always have to insert it at the end. And that's what the definition of a queue is, right? It has to follow first in, first out principle. But for Deques, we don't have to follow that rule. What we can do is we can actually insert from the front, or we can delete from the front. We can insert from the back or delete from the back. Now let's bring our elements. So we have 5 elements, and we can delete from here, we can delete from the last, and we can add one more element here, or we can add elements from the back. So that's the major difference between queue and double-ended queue. So the concept itself, I don't think it's that difficult to understand. It's just that how are we going to implement this solution? I think that's the hard part. So key difference between regular queues and Deques are that insertion and removal can be happen in the front and the rear, so back of our queue. Now we are going to implement these methods, so it doesn't really differ from previous implementations that we made. It's just that we're going to have addRear, deleteRear, deleteFront, and addFront. Now as for our time complexity, it's going to be O1 for axis, because axis is instant, given that we know the index of our element, and we always know our index, right? That's going to be pointed by our first and last pointer. Search is going to be O of n, because we will have to iterate through the queue to get the value that we want. And insertion is going to be O of 1, because we are going to reindex anything, because we don't really have to reindex it since we are using 2 pointers, first and last, to insert elements. Now deletion is the same. It's going to be O of 1, because we don't have to reindex anything. And again, we use first and last pointer to delete our element. Space complexity is O of n, because it's going to depend on the number of inputs that we add to our Deques. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's see how Deques work step by step. We're going to have a Deque or queue with a size of 5. So at maximum, we're going to have 5 elements in our queue. So size is 5, and our first and last will be pointers, and it will be set to -1 initially. Now let's try adding some elements. And for the first one, I want to add to the rear of our queue. So that's going to be addRear, so back of our queue. And let's bring our indexes. Okay, we have our indexes. Since our queue is empty, the last place is currently going to be here at index 0. So we're going to insert our first element over there. That's going to be number 1. And now what we do is we have to change our first and last pointer, and that's going to be at index 0. And this makes sense because since we only have one element, our first and last pointer is going to point to same thing. Now let's try adding one more element, and let's add to front this time. Okay, so you might ask, how do we add to front this time? Because, well, if I look at my queue, I already have an element at index 0. How is it possible that I can add an element? Well, do I make an index of -1 here? Well, that's not the case. What we do is we keep our last pointer here because we're not changing anything, but we move our first pointer to index 4. So our first pointer will be here, and we add our element. So our element is going to be 2, and that's going to be at index 4. So this might look a little weird, but our queue goes like this. So this is going to be the first one, and this is going to be the second element in our queue. The fact that we have our second element at the last index might confuse you, but just think of it like this. It doesn't really matter what our index is. What matters is where our first pointer is and where our last pointer is. So first pointer points to -4, right? So if you were to delete first, we would delete this 2. And if you were to delete last, we would just simply remove this element. That's all we care about, right? So adding and deleting at the end of our queue. It doesn't really matter what index it is, because what makes our queue in order is our pointers, which is first and last. Now let's try adding more elements to see how it really works. I think you will have a better understanding of Deques. Now this time, let's try adding front one more time. So we're going to add the front of our queue. Well, same as before, our last pointer is going to be at index 0. And where do you think our first pointer will go? It will go to here at index of 3. Now this element at index 3 is going to be our first element. So if we were to order this will be first, second, and third. And you see the logic of Deques, right? Again, it doesn't matter how our indexes are. What matters is our pointers. So first and last. Now let's try adding one more element. This time we are going to add to the back of our queue. So addRear. Okay, so our first pointer is going to stay at index 3 because we aren't really changing anything. But where do you think we add our element? Well, is it going to be at index 4, index 0, and then we move element at index 0 to over here? No, that's actually not the case. We actually add our last element behind our current or previous last spot, which was at index 0. So our last pointer will be here. And if we were to add one more element to the front, our first pointer will go to index 2 and we would have 5 there. But if you were to add to rear, our last pointer would go to index 3 and we would add over here. So it's just a matter of where we put our first and last pointers. Okay, that's adding rear and front of the queue. Now let's try deleting some elements. So let's bring our array first, or our queue. Okay, we brought our queue where we have 3 as our first element and 4 as our last element. Now let's try deleting some elements. So let's delete front. Now we know that our first element in our queue is this 3. So we do is we just simply get rid of it. Get rid of this element and we just switch the first pointer to index 4. Now let's try deleting one more time. Delete front. So this time we'll be deleting element at index 4, right? But what do we do with our first pointer? Well, there is no element at index 5, nor is there actually a index 5. So what we do is we just simply move this first pointer to the beginning or index 0. So we get rid of this element because we deleted it. We will keep our last pointer to index 1 and we just simply move our first pointer to index 0 and we bring our elements. So it's not that confusing, right? So if there aren't any more indexes or elements, we just bring that first pointer to index 0. Now let's try deleting at the rear of our queue. So what we do is we go to our queue, look at the last pointer, and last pointer is at index of 1. So we just delete our number 4 and bring our queue. And now we are going to have one element. That means that our first and last pointer is going to point at the same element. Now we can actually use delete rear or front to get rid of our last element, and it doesn't really matter because it's pointing to the same thing. So if we were to do that, we would have our final empty array where we don't have any elements in our queue. So the idea of Deques are that you can add and remove from front or rear of the queue. The hardest part about Deques is that our pointers in general, last and first, is not going to be in order. Well, our first pointer might be at index 4, or index 3. It can actually be anywhere in our queue. It just, what's important is that you just keep in mind that whatever the first pointer is pointing to, that's the beginning of the queue, and where last is, that's the end of our queue. So think of it this way. So 3 is the first one, second, and then we have our 1 here. So again, this is the first element, second element, and third element is over here. Now let's try implementing our Deque. Our Deque is going to take a constructor function, which is going to take a parameter of size, and this is going to define the size of our queue. Next, we want to set a store property, and this is where we are going to store our elements, and that's going to be set to an empty array. Next, we want the size property, and again, this is going to set a size for our queue. Next, we want our first and last property, and these are going to be our pointers, which is going to be set to -1. Now, let's try implementing our solution. So first is we need a constructor function that's going to take in a parameter of size. We need to set our properties. First one is going to be an empty array, and this is where we store our elements. Next is going to be our size, and we are going to set that equal to size. Next, we need our pointers. First one is going to be first, set to -1. The next one is going to be last, and this is also going to be set to -1. And if you want, you can just rename this to front, and this can be rear. I just prefer first and last, so I'll just keep it at that. Now let's try instantiating our Deque. Okay, const, we'll call it just Deque, and that's going to be new Deque, and we need to pass in a size, and let's just pass in 5. And let's console log our Deque or Deque, and you can see that we have our elements or properties where we store our elements as store empty array. Size is 5 because we passed in a size of 5, and our pointers first and last is pointing to -1 because we don't have any elements yet. So that's it for our Deque class. Now let's try implementing our methods. Let's implement our isEmpty method where we check if our queue is empty or not. Okay, so that's going to be really simple. Our queue is going to be empty when our first pointer is pointing to -1, or when our last pointer is pointing to -1. So our solution can be something like return this dot first is equal to -1. And if our pointers are pointing to -1, that means that we don't have any elements, right? Or you can actually write this as this dot last is equal to -1, or you could have written this dot first is equal to -1, because if either of them is -1, it's empty. But let's keep this simple because it's literally doing the same thing. So I'm just going to delete that, and I just want to change it to first. But you can't really keep it to any of these solutions that we just implemented. Now let's try our code. So let's do console log Deque, and we want to check if it is empty. So this should return true, and it's looking good. So that's it for our isEmpty method. Now implementing our isFull method where we check if our queue is full or not is going to be a little bit more complicated than our previous isFull methods that we implemented earlier. For example, like our circular queue or our regular queue. Now we need to consider two different cases, and our case one is adding front or rear of the queue. So let's go over that first. So this is case one, adding front or rear. Now let's say that we are adding to our rear, and when it's empty, we're going to obviously add it to index of 0. So our first and last is going to point at index of 0. Now let's say that we want to add front. So that means that we're going to add it at index 2 now, right? So our first pointer is going to be at index 2, and our last pointer is going to be at index of 0. So it's going to be this number 1 over here. And finally, let's say that we want to add rear. So this time we are going to add it at index 1. So we have 3 at index 1 now, and that's going to be our last element. So our last pointer is going to have an index of 1, and our first is going to stay, and that's going to be at index 2. Now we know that our queue is full, but if we want to check if our queue is full, what we have to do is first pointer equal to last pointer plus 1. If that's the case, that means that our queue is full. Now our first is 2 and our last is 1. So 2 is equal to 1 plus 1, which is 2. Well, that's true, right? So our deck is going to evaluate to true. Now, there is another case that you have to consider, and this happens when we are only adding at the rear of our queue. So let's look at our case 2. So addRear, our first and last pointer is going to point at index of 0. So same as our case 1. And next we add at the back again, so addRear. Now our last pointer is at index of 1, but our first pointer is at index of 0. And we add rear again, so that's going to be our index at 2. So our last is 2 and first is still 0. We know that our queue is full, but unlike before, this formula or this equation wouldn't hold, right? Our first is at index 0 and last is 2. Well, that means that 0 is equal to 2 plus 1. Well, that's false. 0 does not equal 3. So what we have to do is we have to consider our case 2 where we again add only at the rear of our queue. So when that happens, our first pointer is going to be at index 0 and our last pointer is going to be at size minus 1. So the last index, and that's going to be our index of 2, right? And you can see that when our first pointer is 0 and last pointer is size minus 1 and size of our queue is 3. And 3 minus 1 is obviously 2. So when this happens, when our first is 0 and our last is size minus 1, that means that our queue is full. And if this kind of confuses you, we will add elements to our queue and see how this plays out. But I think what we have over here is pretty straightforward. Know that over here and over here, our queue is full, but our first and last pointers are totally different. So we have to consider those two different cases. Now let's code our solution. Our solution itself is going to be easy. What we want to do is return, because we want to return a Boolean value. If first pointer is equal to last pointer plus 1, that means that it's full. And there is another condition, which is our case 2. Or if it is the case that this dot first is equal to 0 and this dot last is equal to this dot size minus 1, that means that our queue is full also. Now we can try to run our code. So let's do console log deque is full, and that should return us false right now. And you can see that it returned false, and that's because we don't have any elements to our queue right now. Now let's implement our clear method where we reset our properties to its initial state. So we want to change our store to empty array, and we want to change our first and last pointer to -1. And we don't have to change our size because size is passed down. So this is going to be really simple. It's just going to be this dot store is equal to empty array. Next we set our first pointer, and that's going to be -1, and our last is going to be also equal to -1. And that's it for our clear method. Now let's implement our addFront method where we add element at the front of our queue, and that's going to take a parameter of a value, and this is the value that we want to add, and we have to check for a few things. Well, if our queue is full, we want to return because we can't really add more elements if our queue is full. And then next, we want to check if our queue is empty. And if it's empty, we want to set our first and last pointer to 0. And this makes sense because if we were to have our queue and we only have one element, that means that first and last is going to point to the only element that's in our queue. And next, we want to check, well, if our first pointer is at the front, which meaning when it's at index of 0, we want to set our first pointer to this dot size -1, and this is the last index of our queue. Just because we have an element at index 0, that doesn't mean that we can't add more elements to the front. We just move our pointer to the all the way back of our queue and just add elements there. Else, we are going to decrement our first pointer by 1, and then we are going to store our value at a given position, which is going to be represented by the first pointer. Now let's try implementing our solution. First is we check, well, is it full? If it's full, what we want to do is we want to stop. And we want to check when it's empty. So else if is empty. If this is the case, what we want to do is we want to set this dot first and this dot last equal to 0. And next you want to check else if it is the case that our first pointer is at 0, what we want to do is we want to set our first pointer to this dot size minus 1. And else what we want to do is we want to decrement our pointer by 1. So this dot first minus minus. Okay, that looks good. And next we want to store our element. So that's going to be at this dot store at index this dot first, and we set this equal to our value. That looks good. And let's try our code out. Okay, let's do Deque, and we are adding front. Let's add 1, and let's console log over here. So console log our Deque. As you can see, we have our first element, which now points to index 0 for both first and last, and our size is 5, and we have our element. Now let's try adding more element. And if you were to add one more element, what do you expect our first pointer to point to? Well, it's going to be at index of 4, right? Because, well, we already have an element at index of 0, so we want to go to the end of our queue, just move our pointer to index of 4 and add the element there. So let's try doing that, and let's just add 2 here. And you can see that our 2 is at index of 4 and our last element is 1. So let's keep adding more elements. Let's add 3. So our 3 is at index 3, and now this one is the first element because we added front. Let's add more. Add 4. Our first element is now 4. Add 5, and now first element is this number 5, and last one is this number 1. And if you were to add one more, we're trying to add 6, but it's not working because our queue is full. So that's it for our addFront method, and let's try implementing our addRear method. Now let's implement our addRear method where we add element at the end of our queue. And also this is going to take a parameter because we are adding elements. Now we need to check, just like before, if our queue is full, that means that we can't add more elements. So if our queue is full, we just want to return. Next we check, well, is our queue empty? And if that's the case, we are going to have only one element in our queue, right? So that means our first and last pointer is going to point to the same element, and that's going to be at index of 0. Else what we do is we want to increment our last pointer by 1, and finally we want to add or store the value at the given position, which is going to be represented by the last pointer. Now let's implement our solution. So if our queue is full, we just want to return. Next, we want to check else if, well, if our queue is empty, what we want to do is we want to set the first pointer and last pointer to 0. Else, we want to increment our last pointer by 1. Finally, we want to store our element at the last pointer and set this equal to value. Okay, that looks good, and let's try our code. Let's do Deque, addRear, let's add 1. You can see that for now it's pointing to the same thing, first and last pointer, because we only have one element. Add one more, let's add 2. You can see that our last element is at index 1, and let's keep adding more. You can see that our queue is full, and this evaluate to full, and our last pointer is pointing at this number 5, and our first pointer is pointing at index of 0. And this was our case 2 for our isFull method, right, where we add at the rear only, and our first pointer is 0, our last pointer is size minus 1. So let's add one more element. When it's full, we won't be able to add more elements, and you can see that there is no element 6 because since our queue is full, we can't add any more. Now let's implement our deleteFront method where we delete element from the front of the queue. So we need some checks. Well, if our queue is empty, we just want to return out of our method because if it's empty, there's nothing to delete, right? And next, we want to store the deleted element to a variable because we want to return that value later. And we want to set the element to be deleted to null because we want to overwrite that value with null. So technically we are deleting it. And then next we want to check, well, if there is only one element in our queue, that means that after we delete our element, it's going to be empty. So if that is the case, we want to reset our properties. And next, what we want to do is, well, we need to handle if the first index is at the end of our queue, meaning it's going to be at size -1. Well, if that's the case, we need to bring our first pointer to index 0 so that we can delete more elements when we have to delete at the front. So we want to handle that case. Else, what we want to do is we want to increment our first pointer by 1. And finally, return that deleted element. Okay, let's start implementing our solution. The first thing is going to be, well, is our queue empty? If it is, there's nothing to delete, so we are going to return. Next, we want to store our deleted element to a variable, and that's going to be at this dot store at this dot first. And next, we want to overwrite that element to be deleted with null. So that's going to be this dot store at this dot first is going to equal to null. And let's return our deleted element here because we have to return it later. Okay, that looks good. Now we need to handle our different cases. Well, if it is a case that our queue only has one element, we want to reset our properties. So if first and last is equal to each other, what we want to do is we want to run our clear method, so that resets our queue. And then next, what we want to do is we want to handle when our first pointer is at the end of the queue. And if that's the case, so else if this dot first is equal to this dot size -1, we want to set the first pointer to 0. Else, what we want to do is increment our first pointer by 1. Okay, now let's try if our code worked. So we are adding a bunch of elements here. Let me comment this one out. Now let's try deleting elements now. So okay, console log deque, we're deleting front. So that should return 1 because 1 happened to be the first element. So uncomment that. So we want to delete this number 1 right here. And you can see that we deleted it successfully. And let's delete one more time. Now 2 is gone. Next, we expect 3 to be gone. Finally, it's going to be 4. And lastly, when our pointers are equal to each other, that means that we only have one element. So after we delete this one, we expect our queue to be reset. And you can see that everything was reset successfully. But now I want to go over our other case when we had our first pointer at the last index. So let's try uncommenting a few, and let's uncomment these and actually uncomment 4 and 5. Now we have our array, and our first pointer is at index 3, and that's this number 3 over here, and last is our number 5. Now let's try deleting our first element, and that's going to be that's 3, right? So 3 is returned. Next one is going to be 2, and we saw how our first pointer changed. So before we deleted it, it's at index 4, right? Because 2 is at index 4. But after we delete that, we want our first pointer to move to index 0. And if we were to uncomment this one more time, you can see that our element was deleted. So we returned our 2. And our first pointer is now pointing at 1. So if we were to delete one more time, we would expect 1. And the next is going to be 4. And finally, when our first and last is equal to each other, that means that we only have one element in our queue, which is 5. And if we were to uncomment this, we would expect our deck to reset to its original state. And you can see that our store is empty, first and last is -1. Now let's implement our deleteRear method where we delete element from the rear of our queue. What we have to check first is, well, is our queue empty? Well, if that's the case, what we have to do is we just have to return from our method because there's nothing to delete. Next, we want to store element that we want to delete to a variable because we want to return that later. Next, we want to overwrite the element that we're going to delete with null. And next, we need to check, well, if there is just one element left in our queue, that means that our queue is going to be empty afterwards. So if that is the case, we want to reset our properties after we delete it. And that happens when our first pointer is equal to our last. And this is the same logic as our add or delete front method. So if it happened to be the case there that there's just only one element, our first and last pointer is going to point to same thing. And next we need to check if our last pointer is at the front, which is at index 0. So if that is the case, we want our last pointer to go to size -1. And finally, we want to decrement our last pointer by 1. Okay, that looks good. And finally, we want to return our element. Now let's try implementing our solution. So first thing we have to check if it is empty. So if it's empty, what we want to do is we just want to return out of this whole thing because there's nothing to delete. Next, we want to store our element to a variable, the element that we are going to delete. And this is going to be represented by store at last index, and we want to override that element we're going to delete with null. Later we want to delete that element, so let's return it right now. That looks good. And now we need to handle our if statements or different cases. So if it happened to be the case that there's just only one element in our queue, and that happens when our last and first pointer is equal to each other, we want to reset our properties. Else if it happened to be the case that our last pointer is at index 0, we want to set our last pointer to size -1. Else we want to decrement our last pointer, so last minus. So that's it for our deleteRear. So now let's test it out. Okay, we'll do console log deque deleteRear. And you saw that we deleted our number 5. So let's uncomment this. So it happened to be the case that our last element is at index 2, and that's our number 5. So when we deleted it, that returned us number 5. And next, let's run it one more time, and we would expect to return 4, which it did. And now our last pointer is at index of 0. And after we delete this number 1, what would we expect? Well, we would expect our last pointer to go to index of 4 and point at the element 2. So let's try deleting it. And it says our size is not defined. Okay, so that means we messed something up. And we forgot to write this over here. So it should be this size -1. I hope you caught that mistake. You saw that our last pointer is now pointing at index 4. So let's just uncomment that one more time. So we saw that our last pointer is at 0. So it's this element. So after we delete that, we want our last pointer to go to index 4 where number 2 is. So uncomment, we deleted 1. And you saw that our last pointer is now at element 2 or index 4. Let's delete one more time. That returned element 2. Now our first and last pointer is pointing to same thing. When it points to same thing, that means that there's just one element in our queue and everything is null. So we only have this number 3. And after we delete this number 3, we would expect our queue to go back to its initial state. As you can see, everything is back to its initial state. Store is empty array. First and last is -1. If you guys find this helpful, make sure you guys like and subscribe. Thanks.